Today I'd like to talk to you about a transformer that you can use to make a good strong power supply. And it's one you may not have heard of or come across. It's a Toroidal, T-O-R-D-O-I-D-A-L transformer, and basically that's a sort of donut shape, and this is the guts of it here. They're quite heavy. They have two windings on top of each other around an iron core. Weighs quite a few kilos. You would have seen the other old particular type. Switch mode. They're good. This is a 24 volt 20 amp that I'm putting on the CNC4A. So I just like to show that to you for comparison. Basically you add your power to the terminals and then you can straight away get your voltage out and connect it. These are a bit more complicated in so much as that's only the transformer part. If you ever pull these apart, you'll see a little transformer in there, about the size of 2 boxes of matches, around that size. So again, there's the comparison. These two also come in different sizes. The particular one I used is what they call 18 volt, 18 volt. They actually have 2 taps, and tap just means wires coming out where it's tapped, like you tap a keg of beer. So that's the same sort of thing, it's just tapped in there, and you have 2 sets of wires. And what makes these unique to the other type is that you can have either double the voltage for the same amperage or the same voltage for double the amperage. So if this is 18 volts and let's just say 10 amps, I can run 20 amps at 18 volts AC, or I can run 36 volts at 10 amps AC. Why is it AC? Because this is a transformer, and you need AC current in any transformer. DC doesn't work. It's the wave of the AC that sends the pulses from one wire to the other. So that's how that works. Quite heavy, like I said, quite expensive. $80, $90 just for this one. Well, that's about 8 years ago. I like to make them up into a box. As you can see, there's your 240 volt and there's your output. Strike strong solid core copper wire. And I like to get an old power supply unit off a computer, take the guts out, leave the terminals, oh sorry, wrong end, leave the 240 volt in and out, the original fan and the switch on it and the fuse on it. On this particular one I added an extra fan on the top. And what's good about that is you can then just get yourself the old PC power connectors, the leads, and plug it straight in the wall. Your bare wiring's out the way. Fans keep it cool, and there's a cabling coming out like it did there. I had this one originally mounted on a separate control box, and I made up a little adapter. They come with this plate, a rubber seal and a bolt, and if you're trying to put this up, put this on, put a bolt on, they soon slide away as the song goes. So you just make up yourself a little plug. Quite simple. Just get your electrical conduit, one size, then get the glue that you use for the water pipes, cut your bit of conduit in half, put the glue on both halves, then squeeze it, so then it will then stretch out to the other side. So you just build it up and build it up that way, and then you get the size that fits. So it might be 2 or 3 pipes, and you make the small ones fit and stretch, and so in the end you end up with a nice plastic core, and that fitted in. As you can see here, this particular one had the 2 bolt holes, and the screw were in there. So that was just sitting in there, and I could slide it in and out, and then I could mount this up quite easily. I had a problem with this one. It actually shorted out, so there was something wrong with the internal wiring, and I couldn't get both voltages out, so I then purchased another one. So what you have to do to get them work, this is just a transformer. You need a bridge rectifier, full wave bridge rectifier. What that means is that AC voltage goes up and down. So what the rectifier does, it only keeps the top part of the wave, and then half a cycle later it then gets the other half. So this is actually shorter, flatter waves, and that's where you get the output as DC. But it's not a straight DC line, it's a series of little humps. So then you have a electrolytic capacitor to help filter it out and to also help store the voltage. One rule, one warning, one caution is that it's got a big zap. When you switch it on, charges that up, and then you tap off your supply from here. The amount you get out is the RMS, I think it's 0.707 of the voltage, but it's stored. So when you throw the switch off, you still got all that voltage stored in there, and it can be a nasty shock or a nasty arc. So what I always do is, and that's what the smaller lead's for, I just put a voltmeter on there. So you'll see, you'll switch off your equipment and you'll still have the voltage. Then you'll see the voltage finally drop down, and that's enough to suck it out of the capacitor, and it saves you getting the shock of blowing up your equipment. A shock, if you live, okay, it hurt. But if you blow up your equipment, you have to spend more money for the same thing. So are they good? They're very heavy. If you want that particular voltage, they're fantastic. High current, reliable. A bulldog, a draft horse, a workhorse, very strong unit. But like I said, probably $100 to get this set up. 80 bucks. Then you have to have your time, your other parts and all that to sort everything out. So it's a better quality power supply unit that costs more and requires more effort to set up. Plug and play basically, so it depends what you want. If you've got a little desktop, small machine, fine. If you want something with a bit more grunt, they come in different voltages. Get yourself a toroidal. As you can see with these photos, this is what it looked like when I had to remove it. It was bolted in. I've swapped over for a different voltage now, a higher voltage. That's why I swapped this one over, and it's working fine on the mill. So if you found this video interesting and informative, full of wisdom, subscribe and I'll answer any questions you have. Tell your friends, spread the word, spread the wisdom. If you didn't like it, tell me why not. And as always, thanks for watching.